Hi guys, so today we are going to be taking a look at a review of linear functions. So this is something you would have talked about in depth in Algebra 1 and saw a little bit in geometry. The first thing that I would like you to do is, if you haven't done so already, please print off the note-taking guide that I've attached on Google Classroom. If you don't have access to a printer, then have a sheet of paper where you can jot down some notes and follow along. Now, I would like you to begin by attempting the try problem on the first page. What you need to do is take a look at the two graphs and identify what the slope of the line is. Just in case you're having some difficulty viewing what those points actually are, this coordinate is 0, 2. And this point right here is located at 1, -1. On the second graph, the 2 points are located at 0, -1 and 5, 1. Go ahead and pause this video and please identify what the slope of the line would be. Hopefully you didn't have any difficulty there. When we're thinking about the slope of a line, remember slope is equivalent to, I'm going to write it right up here, slope is equivalent to rise over run. Or some of you may have used the equation for slope, which is the difference of the y values, so y2 minus y1, over the difference of x values, x2 minus x1. Let's start with the first graph. If I were looking at this graph right here, I'd notice to get from the point 0, 2 to 1, -1, I would need to move right one unit, which is a positive movement, because moving right or up would be positive. And next I would have to move down 3 units. Now moving down or moving left would be a negative movement. If I want to know what the slope is, remember it's rise over run. Rise is the change of the y values, or the vertical movement. So -3 would actually go in the numerator. And the run is the horizontal movement, so the change of the x values. I would put a +1 in the denominator. I'm going to go ahead and rewrite my slope. We always want to simplify the slope if we can, and I can rewrite -3 over 1 as just -3. You know, before I move on to the next one, I do want to mention, if you did use the equation, that's fine. Let's take a look at what we can do here. Let's say I make this my x1, y1, and I make this here my x2, y2. It's okay if you had them swapped, but if I were to find the difference between my y values, so -1 minus 2, notice how that still gives you a -3. And if I find the difference of my x values, 1 minus 0, it's still 1. So both methods will end up giving you the same slope. For my second graph, I personally think it's easier if I give you a coordinate plane just to use rise over run. So that's what I'm going to do here. Again, if you use the equation, it's perfectly fine. But I know to get from this point to this point, I am moving up 2, and up is a positive movement, and right 5 units. We're moving right as a positive movement. So if I wanted to list what the slope is here, slope being rise over run, that'd be a +2 over a +5. Make sure that you can't simplify this any further, and 2/5 is already simplified, so I can move on at that point. Okay. There are 3 major forms of linear functions. There's slope-intercept form, which is y equals mx plus b. Now, this is called slope-intercept because it gives you the slope and the y-intercept. Maybe just make a note to yourself. M is the slope. B is the y-intercept. All right, the next form would be point slope form. Once again, it's called point slope because it gives you a point that will lie on the graph and the slope of the graph. This form would look like y minus y1 equals m times x minus x1, where m is going to be your slope and the point that lies on the graph would be in the form x comma y. Okay? Points are always in the form x comma y for a coordinate plane. Now, I'm going to put x1 because it's actually going to be the number that's right here, and y1 because the number we're going to look at is right here. Notice how we are subtracting these values. That's going to be important for when we see our examples later on in example 3 and example 4. All right. Last one is standard form. Standard form looks something like this. AX plus BY equals C. Now, A, B, and C are all constants. Constants is just another term we use for numbers. So A, B, and C will be numbers in this form. Just a little side note, because I've noticed some difficulty with this in the past. I want to mention that if you have an equation for a vertical line, that would just look like x equals a number, and a horizontal line will be y equals a number. The reason why is, let's say I have something like x equals negative 4. If I were to graph that, I would want to go along the x-axis to where negative 4 would be. So 1, 2, 3, 4. That's right here. In the equation x equals negative 4, negative 4, that x value will always be the same. It is not going to move left or right. The x value is constant. However, the y value can move up or down, thus creating that vertical line there. If I had something like y equals 1, it's the same idea where y is always going to remain the same. That y value is constant. It's not going to move up or down, but it can move left or right, creating a horizontal line. All right, let's move on to example 1. So what we're going to do in the examples of these notes is we are going to first analyze an equation, and then in the next example we would graph it. Starting with example 1, I gave you an equation in the slope-intercept form. Just looking at this form, I can easily identify that the slope, which is located in the M position, would be 2, and the y-intercept, which is located in the B position, would be a negative 3. Part B. Once again, it is in slope-intercept form. My M is negative 7/3 and B is a positive 4, so the slope is negative 7/3 and the y-intercept is a positive 4. Let's take a look at example 2, part A. I have included the steps for graphing above. You're welcome to use that on your homework tonight. But I'm just going to talk you through it for now. The first thing I like to do when graphing is take a look at the equation. This equation is written in slope-intercept form. So once again, I can tell just by looking at this equation that the slope is negative 1/3 and the y-intercept is a positive 4. Now, to draw any linear function or to draw any line, all you really need is 2 points. Well, I already know one point that I can plot on the coordinate plane. That's my y-intercept. So I go on the y-axis and move up 4 units. 1, 2, 3, 4. Using the slope and the point that I've just plotted, I can plot my second point. So my slope is a negative 1/3. What that means is I can move, let's say this is a negative 1, so the negative is associated with just the numerator. I can move down 1 and right 3. Again, because that's rise over run. So I'm moving down 1 and right 3. Another way you could have done this, and you don't have to, is you could have associated the negative with the denominator. So you would have a positive 1 over a negative 3, meaning you could have moved up 1 and left 3. I'll go ahead and do that. Up 1 and left 3. You don't have to do that. I just wanted to show you that you did have another option. And then at that point, we can go ahead and connect the dots to draw what our linear function would look like. You can always do a self-check as well. Notice how if I look at my graph, the y-intercept is at 4, and I can tell just by looking at the shape of that linear function, it is going down. There is a negative slope here. Example 2, part B. If you would like, you can go ahead and attempt this problem on your own. For those of you who still need some help, I'll go through this once again. When I take a look at this equation, it is in slope-intercept form. I can easily identify that my slope is 2 and my intercept is negative 2. The first thing we should do is go ahead and plot our y-intercept so we have a point on the coordinate plane. And then we're going to use the slope to create that second point. My slope here is 2. I'm going to go ahead and rewrite that as 2 over 1. That makes it a little bit easier when I'm thinking about rise over run. So I'm going to go up 2 and right 1. Another way you could have moved, since this is a positive slope, is down 2 and left 1, because 2 negative movements would still create that positive slope. So again, you could have moved down 2 and left 1 if you really wanted to. At this point, I'm just going to go ahead and draw what my linear function would look like. Doing a quick check, I see my intercept is at negative 2, and I had a positive slope, and it does appear like it's going up. It has a positive slope here. Let's move on to example 3. We are now moving on from slope-intercept form to point-slope form. Now, for example 3, we're just analyzing these equations. Slope-intercept form, the slope is identified easily because it's outside of those parentheses. It's attached to the x values. So that 3 right there is my slope. Now, the point, you got to be careful with this, okay? Because the form that we have is y minus y1 equals m times x minus x1. So we have to be subtracting these numbers here in our form. Keep in mind when we're writing our point, it's always in the form x comma y. So my x1 should go here, and my y1 should go here. Let's look at this real quick. Y minus 1. So I am subtracting a positive 1, meaning a positive 1 would go right here.